Okay, so our agenda for today, we are gonna be spending a lot of time putting some data in, coming up with some box plots. So we might spend some more time here and here. Hopefully I'm not keeping you here too long. So let's get started. And there are some people who have this calculator, and there is, I think I told everyone yesterday about a site you can go to get some help with the functionality of that calculator. This is another thing, the setup editor. All right, so this, I mentioned yesterday, like, oh, if you deleted a list, I'll show you how to do that. And then I realized when we got back, I never showed you how to do it. So the way you do that, if you go to your calculator, so I'm probably not on your screen right now, but if I am, maybe in the corner, on your calculator, just hit Stat. And you have 5 options very first. You see at the bottom, option number 5 is Setup Editor. If you ever delete a list, all you have to do is hit enter for that, hit enter again, it'll say done, and it brings back any list that you deleted. So there you go. That's a quick fix for that. And if you ever forget, just, you know, give me a chat or something, and I will make note of that. I'll help you out with that. Okay. So this is something I failed to mention yesterday. When you're describing distributions, of course, we talked about using DISCO as your acronym to remind you of all the stuff. One thing I failed to mention was that you also need to include the context. So if you hung around yesterday when we were going over the homework, we talked about an example of a distribution of average drive distance for PGA golfers. So if I start describing it, I want to say the distribution of average drive distance of PGA golfers is, and then I can say, is unimodal and symmetric. It has an interquartile range of this. You know, I can describe all the different characters, but you want to make sure that you are describing the context. Don't just say, this distribution is unimodal symmetric. Okay. So that's a very pretty cat I'm seeing. Let's move on. That's just a little bit of stuff right there. All right, so we are going to create a box plot, and I'll bring these values up, and you will need to plug all these into a list. It's going to take you a little bit of time, I know that. Just plug it into a list and go to your one variable stats, and I put the instructions right there so that you can find out your 5-number summary. So I will stop. This is 23 values. I know it's going to take you a little bit of time. So let me be quiet and let you work on that. What I'm going to do, now I should point out that this was a random sample of teacher salaries from the 2017-18 school year. Not 100% random sample. I did include my salary in here, and you can guess which one that one is, though you only have a 1 in 23 chance of being right. What I want us to do, annotate here, but don't just write all over this. If your birthday is between January and February, or is in January or February, I want you to mark a line up above, up over here, just draw a line where the minimum is. January, February, show the minimum. March, April, May, show the first quartile. June and July, draw a line for the median. August, September, October, I want you to show the third quartile. And November, December, I want you to show the max. All right, we're getting some things added in. It's important to recognize, I didn't label every single line, so you're gonna have to kind of interpolate from there, figure out where it would fall. And if someone in these groups could label what it is you are doing, like I see someone already put a Q1, I see Max now coming in. Okay, so let's talk about this. So the way that you would actually draw a, I'll come down below and show this. The way that you'd actually draw something, you might have a number line. And the reason you don't draw it directly on the number line is that later you might create multiple box plots and you want to be able to compare using the same scale. So the min, I got 34,871. And so that, to me, seems like it should be somewhere about right here. Maybe there's just not a lot of January and February birthdays. So every one of these is 2,000, so you can jump up to about where 35,000 is. There's the min. The first quartile looks to be a pretty good spot, 38,198. So that's 38,000, yeah, I'd say that's good. I'm just drawing vertical lines right now. The next one is the median, which is 42,303. And yep, I like where that yellow line is. So I'll just continue that. The third quartile is 46,881. So if I come over 2, 4, 6. Yeah, I'm liking where this blue line is. 2, 4, 6. Yeah. So this red line right here should be where that third quartile is. And the last one, 59, so that's right under 60,000. So most people were able to get that just fine. So now that I've got these lines drawn, then it's just as simple as drawing a box over those, and then my whiskers like this, and what do you know, we have our box plot. So again, just to reiterate the point, this is 25% of the data. This is 25% of the data. That's 25% of the data, and that's 25% of the data. So there's an equal number of data points in each quartile, but it's not an equal number of, it's not an equal width. And that's important to note. We'll talk about that more tomorrow, I think. But that is just an important thing. Okay, so we can create box plots. Let me clear all the drawings. Let's not annotate now. So now we're going to talk about outliers. You should have read and already learned about this. And we'll talk more about how the fences are created in a minute. But now we have outliers, where is anything 1.5 times the IQR above Q3 and below Q1. So this is the actual formula that you'd use. You don't need to think about it as a formula, but you take the third quartile, you add 1.5 times the interquartile range. And maybe this is a good time to talk about it, actually. So think about this. If you've got a bunch of data, X sub 1, X sub 2, X sub 3, you know, and these are just data points, and I'm not saying what they are. Let's say we go all the way to X sub n. We don't know how many data points it is. Well, I could put all these, you know, if I was writing the numbers, I'd write them down, right? Then whenever I come up with the median, that would split my data in half. I don't know if I'm doing a good job splitting it in half, but let's pretend that I did. And then the quartiles, we're splitting the halves into halves. Well, with just doing this, this tells us, you know, where these data points fall. But of course, we don't know if this highest value right here is incredibly high. It could be a very high value, something that's way out of what we might expect for the range. So there's a way of showing that. Again, if you read, this is just reiterating stuff you've already seen. But it's important to note that this right here, Q1 and Q3, these are values. Of course, we have the median, but we're saying that 25% of the data falls below quartile 1, and it's a number. So if this was measuring miles per gallon like we were at the beginning of class, if then 25% of all values would be below whatever this Q1 value is. 25% would be above whatever Q3 is. So this range right here is the interquartile range. Let's say that Q1 was 10 and Q3 was 20. We're talking about not very efficient vehicles. And so let's say that's what we've got. My interquartile range is going to be 20 minus 10, so 10. And we're good with that, I hope. So we might expect that 50% of the data that falls in this narrow range, then if something is way beyond that in outside of the quartiles, then that's kind of an outlier. So when we're creating the box plot, we take this range and we want to multiply it by 1.5. So that gives me 15. So now what the thought process is 20 being Q3. And I'll just show that right here where the formula is. So 20 plus 15 equals 35. If I had a car that got 35 miles per gallon out of this data set or above, then that would be unexpected because 50% of the data falls between 10 and 20. If I got something, now this doesn't make sense for this one, but if I got 10 minus 15, if I had -5, that's not possible, but we can say there's not going to be any lower outliers at this point. So anyways, anything greater than 35, so when I'm creating my box plot now, you know, there's like a fence that's going to exist at 35. Any values that's beyond that, I'm going to mark individually. Anything below that can be part of the whisker. Okay, and whatever the value is, the highest value underneath the whisker is where the whisker stops. You don't bring it all the way up here unless you happen to have a value that goes that high up. So I'm going to clear all this. Let's just finish going through it. We also have, we also have far outliers, which is 3 times. This doesn't come up very often, but it's important to know that you have extreme outliers. Whiskers on the box plot will only extend as far as the lowest and highest data points within the fences. So don't automatically, if you have an outlier, don't automatically stretch the whisker out to the fence. It doesn't go that far. It only goes as far as whatever the data point is. Hopefully that all makes sense. And here's what we're going to do with this. I want you to go back to that list that you created, add 1 extra data point. You can see it in the bottom right. And once you have that, I don't want you to just do the 1 variable stats. We're going to find our 5-number summary a different way because we're going to create a box plot on our calculator. And the way we do that, I'm actually going to stop the presentation so that you can see my screen. Okay, that worked. And stop sharing. All right, so you might want to make it where my screen is pinned and you can see what I'm about to do. But I created my data just like you guys did. Now mine is in list 3 because I have other data in here, but I'm going to hit second, and this button at the very top left is your y equals. You might already be familiar with that, but we're going to hit second. That takes us to what's called stat plot. And now you're going to have an option for 3 different plots, and it doesn't matter which one you pick. You can go to the first one, and you want to make sure it's turned on. So if it's off, you want to just make sure that you go and turn it on. Right here, when you come down to type, you can see there are 6 different types of graphs you can create. You want to find, I'm going the wrong way. You want to go over to the right until you get to this one, which is a box plot with outliers. So we want that. And then you can just hit the down arrow. And then you want to pick whichever list includes that you put that data in. So if you put it in list 1, you can just keep it like that. If you put it in list 3 like I did, an easy way of doing that is just hit second and 3. And that should change it. There, yes, list 3 now. So anyways, that is it. I'm gonna make sure that my other ones are off real quick because I plotted some other things. So once you've got that, the way you look at this is you hit zoom right here in the top middle, and you don't have to scroll down, but I just want to show you. If you scroll down, you get to number 9, which is zoom stat. But you can just hit zoom 9 and it'll take you there. And there you can see your box plot. Now the last thing to show you is that you can pull the numbers from this if you hit this button right here, trace. And now as you look at the bottom right here in your screen, it's going to show you your, that's your min right now, but then you can move over. And now it's my first quartile, move over again. It's my median, you get it from there, right? So let's go back into the presentation. And we'll draw this one more time. I'm going to do it just because you know how to create stuff. But now we've got the 34. That didn't change, so I should have a line about here. Oops. So I should have a line about here. I should have that 38. It changed a little bit, but it doesn't change it significantly for us. So 38, so somewhere right there is the first quartile. 42,630 is going to put me somewhere about right here for the median. 47,563 is going to put me about, if I'm doing my math right, about right here for the third quartile. Now, the highest value that's in the fence, that's the next one we go to, is at 59,818. So there we go. There's the box plot. And the last thing I need to show is over here at 71,486. I'm going to have just a singular point, an outlier. Okay, so that was the other point that was not randomly selected. I picked the highest salary in the district as an outlier. Now I can tell you there's a reason for that outlier. It's because that's the JROTC teacher, and his salary is set by the military. So every other teacher gets their salary set by the district. But there you go. Now you know a little more than you used to. Okay, let me clear this. Everyone feel good with creating those box plots? I'll just assume if there's no questions that everyone's good. I lost my participants in chat menu. There it is. All right, comparing histograms. I'm just going to bring this all up real quick. And I'm going to start at the bottom because there is no context for this. But we could pretend that there is a context. We could say that these are, test scores or whatever. Let's just not worry about the context, though. Hopefully that you understand you need to include something about what the data is referring to. Okay, so when you are comparing, when we were describing a distribution, we needed to say something to the effect like the distribution is unimodal and symmetric. The spread is, or maybe the range is this, if we didn't know anything else, or the interquartile range. You talk about all these different features. When we're comparing, we can just compare those features between the two. So I want someone who's willing to volunteer and be brave to unmute and just describe the distribution shape, compare these two together.
The first one has one singular hump, but the second one is more sporadic.
Okay, I can follow that. Can we put that in some of the terms we learned yesterday?
The the first one has. I'm so sorry.
Okay.
The first one has one center of distribution. The second has two.
Okay. So yeah, you
No, wait,
could.
that's comparative centers.
No, I mean I see what you're saying. So we're talking about modes right there.
Mm-hmm.
And the first one I agree is definitely unimodal. The second one is kind of tricky because is that small little gap at 41 to 50, is it like a drop off of, or is
Would
it
that be like an outlier then?
not an outlier, but we could potentially still call this unimodal because there's still
Okay.
this kind of rise right here that, you know, yeah, obviously this bar doesn't come up as high as we think it should maybe, but it might not be because there's a real gap or there's a real drop. It could just be we don't have enough cases to fill it in. So
Okay.
I would actually still argue that that's probably still unimodal. But if we agree that they're both unimodal, what can we say about the skew?
Oh, the first one skewed towards, it has no skew, and the second one is negatively skewed.
Perfect. Well, oh, not perfect. Sorry, but that was good. The second one is skewed. We would actually call that a positive skew because the tail is going off to the right.
I see.
Yeah. So we could call that right skewed or positive skewed. The first one doesn't have skew, so we call it symmetric.
Uh-huh. Yeah, I have that in my notes. I cannot find them though.
No, and that's okay. I mean, that's just something that comes with practice, and it's one of those things, yeah, where we know how to describe it, but we have to describe it now using specific language, and that's the hard part. Okay, I'm going to describe the spread for you, and what we can't say right here is whether one has a bigger interquartile range than the other, whether one has a bigger standard deviation, or anything else. What we can say is that they have the same range. They both go from 11 up to 100, same range. If we had more information, and sometimes they give us a little box of information down underneath with some numbers, then we could say something more about the spread. Okay, but what about the center? Can someone volunteer to say, compare the centers? And just to get it started, one thing that I could ask, where is the center of the first one?
The mean and the median for the first graph are going to be relatively in the same spot. While for the second graph, because of the skew, the mean would be pushed to the right, while the median would be in the same spot as graph one, towards the middle.
Okay, and you're basically correct with everything you said. The mean would, or the median in the second one would probably not be in the same spot as in graph one, but it would be closer to the mode. And you're absolutely right with that observation that because of the skew, it's probably best to compare the medians one to the other. And you're also absolutely right when you said the mean and the median are the same in the first one, or pretty darn close. So what number do you think the median is at in the first one?
51 to 60.
Perfect. And for the second one, where might you put the median?
Probably 31 to 40.
Yeah, maybe 31 to 40. Could be 41 to 50, but you know, I think either one of those is acceptable because we don't have enough data. Well, we can, okay. Technically, we could take the time to count it all up and figure out where the median would be, but quick look, you're right. 31 to 40 or 41 to 50. And that's good. We just compared them. We know that the median in the second one is lower than the one in the right, or the one in the left. And do we have any outliers for this? No. Seeing some heads shaking, no. There's nothing to say. We can just say we both of them don't have outliers. Okay, so that's comparing histograms. Now we did that verbally, but you'd want to write that down. And you want to think of DISCO, distribution shape. Talk about it, compare those two shapes. Okay, this is not just something that we're born with knowing the difference between. So we have to practice with how to describe it differently. Okay. So this is something that if you read the chapter, you already have some familiarity with how to do this. So looking at this, I don't have any writing to say what the circumstance for this data is, but you could probably infer. We have a group of newborns that survived, a group of newborns that died, and we have their birth weights. So we can compare. Which of those two groups has the wider range?
Survived.
Survived. Yeah, and we can see that in the box plot. We could also, something about stats is taking it further and sometimes, answering why that's the case. Well, lots of newborns survive, and you're going to have a really wide range of birth weights for those that survive, but of course, those that died, well, I don't want to say anything more about it. Let's kind of get you to think. So the next question, what percent of the group who died fall below the median of the group that survived?
75%.
That's it, perfect. You can see the median right here for survived falls right in line with the third quartile. So there's 75% of the data. Okay, so if we were going to write a brief comparison, again, I'm not gonna sit here and have us write the stuff down right now. That's stuff you do with practice and you can get help with it. But we would want to maybe, there's really only two things we can talk about, maybe three. We cannot talk about the distribution shape. We don't know. We can talk about the spread. We can compare the interquartile ranges. And to me, these interquartile ranges actually look similar in width, but of course the interval is the same, but the actual numbers that define the range are different. So we could talk about that. Looks like survived went from about 1.75 to 2.75 kilograms. The interquartile range for those that died went from 1.25 to 2.25 kilograms. We just compared them. The center, we have the median. We know where the center is, and that can tell us the median survival, or the median weight of those that survived is 2.25. The median weight of those that died, of those who died, 1.6 or so. Okay, so real quick, just a couple things before we leave this slide. Someone annotate for us and show us for this group. We don't have the histogram. We only see the box plot. But can you guess what the histogram might look like? You don't need to draw all the rectangular boxes. Just kind of draw a curve to show what the shape of the histogram might be. Okay, I like it. That, it's a little bit bumpy, but that's still good. And I agree, we've got definitely the data starts down here and it comes up. The one thing we might want to do is make sure that our mode is a little bit, and that's basically what you just drew. I only edited it slightly. The median might be just a little bit to the right of the mode. Again, we just want to visualize it, make sure that it's it makes sense for us. But it does look like there's some kind of a skew running off toward the right because we have longer tails that way. We don't know that that's what the histogram actually looks like, but we can guess. And I think it's a pretty good guess. All right. And the last thing I wanted to say here, what does this graph seem to tell you? Every data display tells a story. So what is this story being told here?
Babies that survived way more.
There you go. And that's basically it. So, you know, it's not like a major, you know, epiphany that you guys are having by seeing this, but lower birth weights tend to be associated with higher mortality rates. So that's, you know, it's a very visually striking, and it shows us that. Okay. So let's look at this. We're going to look at this together for a second, and I need to explain what these graphs are. So you have, this is actual data. You can see the dates that this came from. There's favorability ratings, which says X% of people like, and this is going back to the 2016 election. So X% of people liked Hillary Clinton on any given day based on polling, and X% disliked her. And when you get the difference between those, you're going to get a net favorability. So in this case, 18% more people disliked her than liked her. On this day, about 10% more disliked her than liked her. And the red represents Trump. He is, of course, represented in both of these graphs. Now we have Biden for 2020. So that hopefully makes sense. What you see down at the bottom, this is the difference between the candidates. So notice right here, whenever Hillary and Donald were closer, there's not much difference between them. But then right here, it widened out, and you get this bigger gap. And you can see how that changes in this graph too. Notice that the scales are not the same between 2016 and 2020. So what I'm going to have you guys do, I'm going to put you into breakout groups. And we're talking about this in terms of statistics, okay? But in the Canvas classroom, you go to August 20th, which is today, and you look there, there's this picture, this exact slide. It's just right there when you go to the August 20th class. Pull that up, and in the breakout room, talk about this. What do you see in these graphs? All right, we won't answer that here. Let me create your breakout rooms. And I'll need to get out of this. Okay, here they come. So you can join, go to the Canvas classroom, find this, and talk about it just a little bit. Now, only for about a couple of minutes. Okay, so I tried to go into every graph just to see if you guys were actually chatting and make sure everything was going well. I wasn't trying to listen to the conversations too closely. I just want to make sure you were chatting. So did you guys come up with anything you could say when comparing these two time plots?
You said that the second one was a lot more consistent than the first.
Okay. And that, I can see that too. I agree. Yeah, it seems like there's...
Yeah, in the first one you see like these giant humps compared to the second.
Very good. I agree. And you don't have to, I'm not asking you to dig too deep into all this. You're about to plug some data in. And what I want you guys to do is now look at this, because we're talking about comparing box plots. That's what we're going to do with this. We're only going to be looking at this data down at the bottom. All right, so I have all these numbers in a, the classwork still on the Canvas page. You might have seen that. And all these numbers. Now, when you go there, you're going to see it's 2 pages. It's a 2-column table. All 30 of those values, actually there's 31. All 31 of those values for 2016 are in a table. It's 2 columns, and then 31 values are on the next page. So that's a lot of values for one person to put in. So when you get into your breakout rooms again, half of you plug in the 2016 data, half of you plug in the 2020 data. And then we will come back and we will create some box plots. All right, but I'm going to put you back into your breakout groups. You already made it to the Canvas class page. So just open up that PDF that's under classwork and split up how you're going to create those lists, and you can compare them in your groups. We'll come back in a little while. I know this is going to take you some time. So let me, no, didn't want to, there it is. All right, let me open those rooms up again. All right, so just to wrap this up, I'm not actually going to make us draw those box plots. Hopefully you guys feel comfortable enough with that. What I'm going to do is I'm going to show you the results. Now you can create multiple plots on your stat plot. So you could have created for plot 1, you know, the data from 2016, and then for plot 2, the data from 2020, and it will show both of them and compare them on the calculator. You've probably learned today that using the calculator to plug in a lot of values is time consuming and not very fun. And I think I mentioned earlier, as we move forward, there's going to be less of the data entry type stuff. So that's good to know. But anyways, this is what it would have looked like if you had finished it up. Hopefully you guys got these same numbers, or and if they're off, it might be because I made a mistake in data entry. So they should all be fairly close though. So what I want someone to do is to notice something and describe these box plots. Compare these box plots.
There's only one fence for the 2020 box plot.
Well, what you're talking about right here is like the whisker coming off. The fence is what determines the outliers, which would probably fall about right here. And you're right, in the display, there is only one whisker coming off. Technically, you'll notice right here, third quartile is 15.5 and the max is 15.6. So technically there's this really tiny one, but by appearances, you're absolutely right. Anything else that you can notice? And remember, compare the spread and compare the center.
2020 is much more even. Like,
So, oh, like, you mean, what's another word for that?
symmetrical.
Symmetric, there you go. And you're right. It does look a lot more symmetric. I like that observation. Again, we can't completely say that since we don't have the shape of it, but we could guess that it's symmetric. Okay, any other comments on the shape, or not the shape, but the center or the spread of this data?
2016 has a larger range.
Larger range and larger what?
Quartile.
Maximum.
Larger maximum. What's another method we like to use for spread?
Interquartile range.
You got it. Has a larger interquartile range, definitely. And so if we compare the centers, I'll just say this real quick. The median of this one is higher. So even though this has a wider there's more variation in the data here, more variability, the median value is actually higher here. The median value is lower in 2020, but it's way more consistent. It looks like it's probably symmetric data and low variability. So very good. So what do you think? Well, you know, actually, I think we'll probably just call that good. So there are a lot of types of questions that I did not cover. It's vital that you guys are going through and doing the homework, just because I can't possibly cover all the different things that could come up about box plots and histograms and all the other displays we've learned. So your homework for tonight is this right here. It's on the website. It's on the Canvas page, so you don't need to copy it right here. But anyways, we are going to try our first FRQ tomorrow, which is a free response question. If you want to get some help, I'm going to run through 3 problems from the homework. If you want to hang out and see how I go through those, feel free. Otherwise, you guys can enjoy your day. So have a good one.
Mr.
I will.
Davis.
All right. Have a good
Hey,
one.
Mr. Davis.
Bye.
Mr.
Have a good
Davis.
Yeah.
I have a question. So how do you want us working on the PDF? Do you want us to print it out, or do you want us to like somehow do it digitally?
Well, because it's just turned in, it's because it's not being turned in, you can just write it off on a piece of paper what your answers are. I am going to come up with times that I have you submit stuff, and when I have you submit it, I'll come up with a way for you to do it. But for tonight, yeah, just look
cool.
at the
Thank you.
PDF, write it on a piece of paper. Good question.
All right, thank you, Mr. Davis. Have a good day.
All right, you too. Okay, let's get started on looking at the homework. And all right, where did I put my, oh, I think I've dropped it. I had to get my stylus. All right, so when we're looking at question number 12, we've got a histogram and it gives us some data to work with. So that's really nice. And now we don't need to worry about number crunching, at least not too much. Which statistic would you use to identify the center and spread of this distribution, and why? I bet someone out there could answer this one. All right. I know you're hanging out to get help, and you didn't necessarily expect to have to answer.
Well, would it be the median?
Yes, median and what?
Standard deviation.
Not standard deviation.
IQR.
IQR, that's it. So the median, and so I kind of showed that right there as connecting them. It's either going to be mean and standard deviation or median and interquartile range. So yeah, that's what we would use because this is skewed to the right. I think we can all see that. How many parks would you classify as outliers? This takes a little bit of math, but we don't have to do anything too intensive. We have our third quartile and first quartile, so I can just do 78 minus 28 to get 50 as my IQR. Okay, now multiply that times 1.5 because that's how we determine the fence, which gives us 75. Now the 75 on its own doesn't mean much, but what I can do is I can come up to the third quartile. First of all, if I go to the first quartile, which is 28, and I subtract 75, not equals, and I subtract 75, that doesn't make any sense. Have negative number. So we're not gonna have negative number of campsites. So let's just worry about the other one. All right, there we go. So we have third quartile 78 plus 75 puts it at, I just want to make sure of something, 153. And that means this is our cutoff. Any value greater than 153 is going to be an outlier. And 153 is about right here. So I definitely have, now I have to look over here on the left. That is, you can see that's 1. So we have 1 each of outliers there. I could potentially have an outlier right here, but the thing is, that is a bin that goes from 150 to 160, I think. So just to err on the side of caution, I'm gonna say I don't know if either of those are outliers. They could both be, they could neither of them be. So let's say we know for sure we have 3 outliers. And that's what I would say. I would classify 3 of them, and we can create a box plot now. And luckily this is simple to do when we have the data, the 5-number summary given to us. So I can start with the I know it goes from a min of 0 up to a max of 275. So my box plot, okay, that's 275, starts right here at 0. I'll go up to the first quartiles, 28. Oh, I should add my other numbers. So I tried to space it a little better. It's not working out great, but anyways, 28 is the first quartile. I'll put it about right there, seems reasonable. 78, about right here, seems reasonable. That's the third quartile. The median I skipped over, 43.5, a little bit below half. And now the highest value that is within the fence is right at 150. So I know I have a number there. So now I can create the actual box plot. These other three values that are outliers, I need to mark them. So at 175, I've got an outlier. At 200, I've got an outlier. And at 275, I have an outlier. Okay, and then for the last part, when it's asked to describe the distribution, we actually have the histogram. So we'd always include the context. We'd say something, I'm not gonna write it out, but the distribution of number of campsites at public parks in Vermont, I just took that straight from the question prompt, is, now I would say it's unimodal and it's skewed to the right. So I just described it, that's the DI of DISCO. S, the spread. I do have, because it's skewed, I'm gonna talk about the interquartile range. The interquartile range is 50. And then I might say it goes from 28 campgrounds to 78 campsites. The center, I'll use the median. The median number of campsites is 43.5. And outliers, I do have outliers, so I'd say there are outliers at 175, 200, and 275 campsites. And that's really the description of the distribution. If all I had was a box plot, I might not say anything about it being unimodal, but I might be able to say it seems to be skewed to the right. That's fair to say. Okay, so are there any questions on number 12? Okay, yeah, we can come back to it if something comes up. Let's see. This right here, we're comparing two histograms. The National Vital Statistics Report indicated that nearly 300,000 Black Americans died in 2003 compared with just over 2 million white Americans. Here are histograms displaying the distribution of their ages at death. Describe the overall shapes of these distributions. Now the first two questions, because the next one says, how do the distributions differ? Let's just go ahead and compare these two. So there's a lot of similarities here. We can see that definitely as people get older, the value goes up, the percent share goes up. But what we should notice in this is that the shape of the histogram for whites looks something like that, and for Black, it looks more like this. And you'll notice that the variation in the data, the variability of the data, seems to be a little different. So there's a steep drop off with white Americans compared to Black Americans. And so when we go through DISCO, the distribution shape, they're both unimodal and skewed left. Though we might make comments about the fact that the mode, well, this is where we talk about the center. The center of the data for Blacks tends to be to the left of the center for whites. We don't know exactly where it's at, but if we compare the centers, that being lower means that Black people tend to die percentage-wise at younger ages. Okay, spread, because the shape of this distribution is not as steep of a drop-off, we might, even though we don't have numbers here, we could say that the Black American percentage distribution seems to be have wider variation, then maybe a larger standard deviation, a larger interquartile range than white Americans. We don't know what those numbers are, but it seems from the graph that's going to be true. And hopefully just visually you can confirm that and understand it. All right. And then outliers, the one thing we might want to show here is that it's almost, looks like we have some outliers from 0 to 4 for the Black American percentages. All right. Now, I think as long as it's showing that you have a real understanding of how to interpret these graphs, there might be differences in the ways of describing it, but that's, you know, yeah, that's pretty good. Now, the last little thing here, where did these plots violate the rules for statistical graphs? Well, we can see at the very top bar, 85 years and older. That can be a very wide bin. And at the very bottom, everything else is 10 years except for the bottom, it's only 5 years, 0 to 4. So, you know, there are probably good reasons, because this is real data, but there are probably good reasons why they don't have it split exactly even. But it does technically violate the rules for histograms. You'll find that rules are broken all the time in statistics. But we have to learn it a specific way. Okay, so not much more to say on that one unless you have questions. Okay, then the last one here, this is, we got 4 box plots, and if it only looks like 3, this one right here is a box plot. We either have one vehicle with 5 cylinders, which I didn't even know existed, or we have multiple vehicles that all have the same fuel efficiency. If I gave you a data set that was just 5 over and over and over again, you know, then here's the box plot for it. There's 5, there's a box plot. All right, so that is a box plot, but we can almost not consider it right now. Let's just compare the 4, 6, and 8. And what is something that stands out to you when you compare the 4, 6, and 8 cylinders?
The more cylinders, the less fuel efficient the cars are.
Exactly. And when you talk about that, you're talking about the medians. All right. So the median fuel efficiency in miles per gallon goes down as the number of cylinders goes up. Is there something else we can talk about?
It seems like the more cylinders have a lower range than, or excuse me, high cylinders have a lower range than the cars with less cylinders.
Yeah, and that's exactly, that's it, that's perfect. That's the other thing that we might notice. So here we're talking about the spread. The spread of the data tends to shrink down with higher cylinders, and the gold standard for that with this kind of data is IQR. We could say the IQR tends to go down. We can use actual numbers because we can see approximately, you know, that's 34, and this is maybe 28. So you could say like the IQR goes from 6 to, I'm gonna guess this is like 4 to 2. So the IQR goes from 6 to 4 to 2. And, you know, when we can show that comparison and how the spread is changing, you know, you don't have to absolutely mention everything, but I will say the center and the spread are going to be key things. If there is an outlier, you might mention, honestly, the outlier doesn't matter a whole lot here, but you get the idea, hopefully, with that. We don't know anything about the distribution shape, so don't even mention anything about that. Or just be careful what you mention. You could talk about the skew perhaps, but that doesn't, well, you could say whatever you want as long as it's statistically valid. I'll just say that. Any questions on this one? Okay, that's as much as I was going to go through for today for the homework, but I am happy to hang around. If you guys had other questions, let me do this real quick.
I think I'm good.